Okay, we can. I think that we can start.
Right, then shall I just go ahead and share my screen?
No, one moment. Just let me present a bit the session.
Okay. Okay.
Sorry. Okay, so welcome everybody for coming here for the first paper session of today. We will have 4 presentations today. And you can see the list of papers that we are going to present on our website. So we will start from Andrea. So she's the first one. Andrea, okay, one moment. Andrea comes from the Global Catastrophic Risk Institute, and she's going to present her work on the ethics of sustainability for artificial intelligence. So the floor is yours. You can start presenting.
All right, thank you. Then I'll just share my screen. Let's see here. Can you see my screen?
Yeah.
There we go. All right, thank you. So as you said, my name is Andrea Uwe. I'm an environmental moral philosopher and a research associate at the Global Catastrophic Risk Institute. So this paper is co-authored by my colleague Seth Baum and myself. And in this paper, we do essentially four things. First, we demonstrate that the ethics of sustainability in general to date tends to be a bit unclear in the sense that it fails to be explicit about the ethical dimensions of sustainability, and that this ambiguity has been reproduced in work on AI and sustainability. And we show this through quantitative analysis of the ethical dimensions of existing work on AI and sustainability. And following that, we advance an argument for a concept of sustainability that is particularly long-term oriented, that is non-anthropocentric. And we also suggest the loftier aspiration of optimization rather than sustainability. And then we end by pointing out the implications of this for AI. And I should note that much of the discussion in this paper is not specific to AI. And the reason for this is that the ethical dimensions of AI and sustainability are to a large extent the same as those for sustainability in general. So therefore, to understand the ethics of sustainability and AI, it is essential to first understand the ethics of sustainability. So in its essence, sustainability simply refers to a kind of particular characteristic of systems as they change over time. But in common use, sustainability, of course, is often considered a good thing and typically associated with some forms of environmental protection. So therefore, the concept has ethical dimensions. However, as the term sustainability has been so widely applied over the past decades, it's also to a large extent been watered down. So we point out specifically 4 ethical dimensions of sustainability that we consider important, but rarely find to be made explicit in the literature. And those are: what should be able to be sustained and why? For how long should something be able to be sustained? How much effort should be made for sustainability relative to other important societal goals? And how does sustainability fare in comparison to more ambitious aspirations, such as optimization? So the reasons why something should be able to be sustained typically derive from what we in moral philosophy refer to as intrinsic value and instrumental value. And intrinsic value refers to something that is of value for its own sake or as an end in itself, whereas instrumental value is valuable because it promotes something else of value. So for sustainability, this speaks to what is to be sustained for its own sake and what is to be sustained because it promotes that or those other things that are to be sustained for their own sake. And common conceptions of sustainability, such as the 87 Brundtland report and much of the discourse on sustainable development that has followed it, are anthropocentric, meaning that they only aim to sustain humans for their own sake and sustain the natural environment to the extent that it supports humans. So being explicit about what it is to be sustained and why, therefore has very strong implications for different actions towards sustainability. And the second ethical dimension speaks to how long something is to be sustained. There's a big difference between sustaining something for a few days or indefinitely into the distant future. And unfortunately, discussions of sustainability are often not precise in their considerations of timescales. For example, again, with the Brundtland report, it has emphasis on future generations, so that implies a timescale of at least decades, but how many future generations? And this is important because the actions needed to enable the next few generations to be sustained often differ significantly from the actions needed to enable the same for every generation that could ever exist, for example. And the third dimension speaks to the effort we put into sustainability relative to other competing values. And for example, again, with the Brundtland definition, it was specifically crafted to acknowledge the competing values of present and future generations. But many choices involve trade-offs. For example, depleting natural resources often benefits present generations at the expense of future generations. So moral guidance about sustainability must consider how to evaluate trade-offs between sustainability and other moral goals. And this also speaks to more fundamental questions about the degree of effort to take to achieve ethical goals in general. So for example, should a person or an organization give sort of everything they've got towards sustainability, or is just a little effort enough? And this consideration leads to the four questions, namely whether sustainability itself is really enough, or should we work toward more ambitious goals? So sustainability really means enabling something to be sustained in at least some minimal form, whereas optimization means making something be the best that it can be. And for example, again, the Brundtland report calls for the present generation to act without compromising the ability of future generations to meet their needs. Now, the basic needs of human life are to approximation, food, clothing, and shelter. So following the report's call could result in a society living forever at a sort of minimum subsistence level of consumption, whereas making sure that the present generation acts to enable future generations to do much better than meeting their basic needs is more ambitious. So after laying out these ethical dimensions of sustainability in general, we performed a quantitative analysis of AI ethics principles and of research on AI and sustainability. And we mapped our findings according to these ethical dimensions. And we found that, somewhat unsurprisingly, these trends of the sustainability literature has been reproduced in the AI literature. For example, in terms of what is to be sustained, most sources focus on some form of environmental sustainability. But there were some that were on sustaining the AI system itself, on sustaining organizations, healthcare systems, and other miscellaneous things. And in terms of why something is to be sustained, in other words, what is intrinsically valued, we found that most intrinsically valued humans only, with the natural environment or AI systems having instrumental value for the sustainability of human populations. But there were a few that also intrinsically valued non-humans, such as other species, biodiversity, and ecosystems. And others, again, were ambiguous. And there were also frequent references to these broader treatments of sustainability, such as the Brundtland report and the Sustainable Development Goals. And these are likewise anthropocentric. And there were a few references to future generations, but most sources didn't specify timescales of sustainability, and none really specify the degree of effort to be taken towards sustainability. And you can find examples from these analyses in the appendices of the paper. So following this analysis, we advance an argument in response to these four ethical dimensions. And we encourage others in AI ethics to adopt this concept. And specifically, we argue for long-term, non-anthropocentric sustainability, and we make a case for optimization of intrinsic value rather than sustainability of intrinsic value. So by non-anthropocentrism, we mean that more than humans are worthy of being sustained for their own sake. There can be reasonable disagreement as to what non-humans are of intrinsic value, but we think that there's really no sane basis for refusing to intrinsically value any non-human lives or entities. Humans are members of the animal kingdom, we are part of nature, and morally significant attributes such as the innate drive to live and flourish or to experience pleasure and pain are not unique to the human species. And if one holds more holistic conceptions of intrinsic value, then humans are only one part of greater systems such as ecosystems. And our call for sustainability to be long-term oriented is specifically motivated by an ethical principle of equality across time. And in essence, this means that no one or no thing or moral significance is to be disadvantaged because of the time in which they happen to exist. And taking such temporal equality seriously means to include attention to all future time periods. And that includes the astronomically distant future. So combined with our call for non-anthropocentrism, this means that sustainability should aim to sustain that which is intrinsically valuable, not only a few generations ahead, but into the distant future. And thirdly, paying attention to the distant future is also the reason why we call for optimization of intrinsic value, rather than only sustaining intrinsic value. First of all, the astronomically distant future offers really astronomically large opportunities for advancing intrinsic value. And these opportunities are much greater than those available for the present time and the near-term future. So this therefore suggests a high degree of priority of actions oriented toward the long term. And secondly, we think that moral progress in all forms should be a major societal goal. And in the paper, we support this point through a perspective from the physics of the long-term future, where Earth will become uninhabitable in roughly 1 billion years. And this means that long-term sustainability of any Earth-originating entities therefore requires that human civilization expand into outer space, which further requires that we maintain the sort of basic functionality of civilization so that space expansion can eventually be pursued. And that includes handling major threats such as global warming, pandemics, and nuclear warfare. And this is the case both for sustainability and intertemporal optimization for the distant future. But if you look ahead, these goals point in different directions. Because sustaining Earth-originating entities into the distant future only really requires some minimal space settlement over very long timescales. But in contrast, optimization of long-term intrinsic value entails space expansion sooner and at larger scale in order to sort of fill the universe with whatever is of intrinsic value. And this also matters for what is to be sustained or optimized. For example, if humanity fails to settle in outer space, then other Earth-originating entities would also die out in a billion or so years, so if not sooner. So what's the role of AI in these considerations? First of all, it means that current and near-term forms of AI should be applied to addressing immediate threats to global civilization, such as global warming and environmental protection, towards improving long-term sustainability and optimization. And secondly, future forms of AI that are highly advanced could be particularly consequential for long-term sustainability due to its potential. Long-term AI is really seldom discussed in relation to sustainability, but in this perspective, it could actually be more important for sustainability than near-term AI. And there are particularly 3 roles of relevance long-term AI can play for long-term sustainability. The first is that it could bolster efforts to address threats such as global warming and pandemics. And secondly, it could pose a threat of its own, especially for sort of runaway AI scenarios. And thirdly, it could play an instrumental role in space expansion. And there's also particularly this dilemma with long-term AI in that it can both be a threat and a tool for addressing other threats, which speaks to the potential gains and risks to sustainability of such AI being developed sooner versus later. So these are among the AI issues that can be of profound importance for long-term sustainability. So to summarize, this paper surveys the ethics of sustainability. It analyzes the ethical basis of existing work on AI and sustainability, and it presents an argument for a non-anthropocentric long-term conception of sustainability. And on this basis, we call for further work on AI and sustainability to be specific about this ethical basis, to adopt the concept of sustainability that we call for, and in practice, that really entails a focus on applying AI to addressing major global threats in order to ensure that the long-term sustainability of the resource base needed for civilization and for pursuing opportunities such as space expansion. Let me end by just emphasizing that a fundamental aspect of sustainability is exactly its future orientation. So if a moral principle of equality across time is to be taken seriously, it demands an attention to the sort of big picture, distant future, and to the ways in which near-term actions can affect it. And actions involving AI are among the most significant ways to affect the distant future. So the field of AI therefore has really special opportunities to make an astronomically large positive difference. Thank you, and I hope you'll read the paper.
Thank you, Andrea, for your presentation. It was very nice. Okay, let's see if someone from the audience have some question for you. Please write on the chat if someone has some question. I have one in the meanwhile. Actually, I had a small chat with Seth Baum, with the other co-author. I was I'm not from a philosophic field. I'm a computer scientist. But my question is because here you are talking of a non-human approach, so looking at also non-human things, let's say. But if we are humans and we are looking to them, so we are managing them, they are still things that are viewed by humans. So we are approaching the non-humans things with the eyes of the humans. So how it's always humans in the end. So how, what do you think about this thing?
Yeah, so that's there's a difference. Like, sure, how humans value non-humans will always, to some extent, come from a human perspective. But there's still important differences following from that in terms of how humans value non-humans, whether we do it for their own sake or only for how they kind of benefit us, has different implications for how we should treat them. So what you're pointing out is more a kind of like meta issue.
Yes.
It's but in terms of sustainability, that's it's not that essential, really. It's more about the actions needed to be taken towards sustainability. So if, for example, if we pursue sustainability that recognizes intrinsic value in non-humans, even if that comes from the perspective of certain humans, it bears different implications for how to sustain those entities, for example, into the distant future, than whether we only protect them for our own sustainability.
Okay, thank you. There is something in the chat. Okay, no, sorry, it's the question here. Okay, so if there are no other questions from the audience, I think we can go to the next speaker. Thank you, Andrea.
Thank you.
Okay, the next is Abhishek.
Yeah,
okay.
Thank you.
One moment.
Abhishek.
Yes.
Okay.
Okay. Abhishek comes from the National College of Ireland, and he is going to speak about his work on an object detection and scaling model for plastic waste sorting. So the floor is yours.
Thank you. I'll be sharing my screen now. Can you see the screen now?
Yeah, it's okay.
All right. So hello everyone. My name is Abhishek Padalkar, and I'll be presenting my paper on an object detection and scaling model for plastic waste sorting. And the co-authors are my professors, Dr. Pramod Pathak and Dr. Paul Stynes. So yeah. So starting with a mind-boggling fact and a question. Did you know that only 10 to 14% of approximately globally produced plastic is recycled on an yearly average? And the question remains, why so less even in today's date? So plastic products we use on daily basis are made up of different polymer types or plastic types according to their usage. There are a total of 7 different polymer types or plastic types which can be recycled as shown in the figure. So each type has a number assigned to it. So 1 for PET, 2 2 for HDP, 3 for PVC, and so on. And PET, HDP, all these acronyms are basically the polymer names. So PET is polyethylene terephthalate, then HDP is high density polyethylene, PVC is polyvinyl chloride, LDP is low density polyethylene, PP is polypropylene, PS is polystyrene, and there's other types. So in order to recycle plastic waste, these different types of plastics cannot be mixed together. Thus, plastic waste sorting is the initial step before actually recycling the actual recycling process is started. Meaning these different types of plastics are recycled differently in order to achieve higher quality product and thus better market value. Thus, sorting of accurate sorting of plastic is still a challenge today in order to increase the recycling rate. So currently, research only focuses on smart waste segregation when we consider smart waste management. And smart waste segregation is basically segregating all types of waste. But while we now know that for plastic recycling, plastic waste needs to be further separated into the individual types. And image-based plastic waste sorting is still highly understudied. So a study with the image-based PET versus non-PET plastic waste is the only study that was performed based on color histogram Canniage filter that comes under the smart image plastic waste sorting. So thus, for this research, it is the state of the art to sort plastic waste. But the challenge here was that mainly it can only sort PET plastics waste from rest of the plastic types. And the second, that the method used to extract PET features was simply an image histogram method, which makes hard to extract multiple classes based on color features, and the method also lacks to extract texture-based features. So the aim here was to investigate to what extent object detection and scaling models can precisely and accurately sort plastic waste. Okay, the approach adopted to carry out this research was simple. In waste sorting centers, waste is usually passed through a conveyor belt. Thus, a labeled plastic waste dataset is selected that imitates a similar background to the conveyor belt. And in order to perform plastic waste sorting, intelligent object detection models were trained and tested on the dataset. The models were compared based on mean average precision, which is also called as MAP, then accuracy, FN scores, train and inference time for plastic waste object detection. Okay, the major contribution of this research is a novel approach of using object detection and scaling models that utilizes feature pyramid networks to extract visual features and detect small objects better in plastic waste sorting. Moving on to how we approach to select the models for plastic waste sorting. So as this study is the first study publishing object detection approach in plastic waste sorting, there were two major criteria that we looked while selecting the models for this task. First is the model must be able to extract visual features and texture features better as plastic are transparent and has similar visual properties. And the second was it must be able to detect small objects, medium, as well as large objects accurately, since plastic waste can be of any size. To this criteria, an object detection and scaling models such as Scale YOLO V4 and EfficientDet were selected as they portray state-of-the-art result for the above criteria based on COCO dataset. A small introduction to an object detection and scaling model. So these models have scaling ability to them, by which they can increase in size internally. These models can increase in width, depth, and resolution by a factor which makes a model to extract more features. On the other part, these models also utilizes feature pyramid networks that perform bottom-up and top-down convolutions, which are connected laterally, because of which high semantic information with high resolution is extracted. With this scaling ability, the additional feature pyramid network enhances feature extraction and makes it possible to detect small objects as well. So as shown in the figure, you can see that these models can scale up in width, depth, and resolution, thus getting larger in size internally. We don't want to focus here on the working as much, but the selection of models for this sorting task. So for this experiment, we selected two versions of the object data and scaling models, the baseline versions towards the left and the fully scaled version towards the right. Thus, scale YOLO V4, CSP, and EfficientDet D0 were the baseline models, and fully scaled models were scale YOLO V4 P7 and EfficientDet DX7X. The selection was simply made to understand the performance of these models on the plastic dataset. So moving on to the methodology, the research followed a 5-step process of data model building pipeline. So first, the Badabat plastic waste image classification dataset was downloaded. Second, this dataset was converted into an object detection dataset by manually annotating the bounding boxes. Also, an auto orientation pre-processing step is performed to have different rotations of images for diversifying the dataset. Third, the dataset was uploaded to RoboFlow web app, which transformed the format of the dataset into a desired scale YOLO V4 and EfficientDet model format. This formatted dataset were splitted into train, validation, and test set with 70 is to 20 is to 10 ratio respectively. In the fourth step, scale YOLO V4 and EfficientDet models were trained on the final transform dataset. The models were trained over 100 epochs. These trained models were then used for inference on the test set. In the fifth step, involved evaluation of the trained models over the test set based on mean average precision, accuracy, train time, and inference time. Oh, all right. I'm sorry. Yeah. The plastic dataset used in this research was the Vadaba dataset. It is the only plastic waste dataset with ground truth plastic type labels. So this dataset contains a total of 3,960 images and 4 plastic types, namely PET, HDP, PP, and PS, as discussed earlier. So this dataset contains 2,200 images, PET images, whereas 600 HDP images, 640 PP images, and 520 PS images. Moving on to design. The design of this research is straightforward. Like get the plastic waste images, pass them to the train object detection and scaling models for inference, and the models then make the inference to detect plastic object type with bounding boxes around it. Moving forward, the models selected scale YOLO V4 CSP, P7, EfficientDet D0, and D7X were implemented on Google Colab Pro machines, having 32 GB memory and 16 GB graphics. These models are pre-trained on COCO dataset, thus taking pre-trained weights as a starting point. These models were then fine-tuned on a plastic dataset. Moving on to results. So the models were evaluated and compared based on mean average precision, class prediction accuracy, and individual F1 score values. So from the table, it is seen that scale YOLO V4 CSP outperform all the other models in terms of mean average precision, accuracy, and F1 score. It is also seen that EfficientDet models perform poor as compared to scale YOLO V4 models. Also, the results demonstrate that the scale models perform inferior results to that of the baseline models. It is suspected that since the scale models are larger in size, with the large number of parameters, the dataset size used to train these models is relatively small. Also, 100 epochs are less to train such a complex model. Whereas the baseline models, being lighter and smaller in size and parameters, they perform well on the given dataset comparatively. For the F1 scores, all the models achieve higher F1 values for PET plastic objects, whereas PP and PS were less precisely detected as compared to PET and HDPE. And as discussed earlier, a study on image classification for PET versus non-PET plastic objects using color histogram Canage Gaussian filter was the state of the art in an image-based plastic waste sorting. with classification accuracy of 75.68%. So this research demonstrated that scale yellow before significantly outperforms this state of the art by 21%. Next, the models were also evaluated and compared by train time over 100 epochs and inference time on the test set. So as seen in the image, the bars are the train time in hours, and the line indicate the inference time in seconds. So the scale yellow V4s consume only 1.48 hours to train and 0.02 seconds to make an inference test, outperforming the other models. So now to conclude, aim of the research was to explore the ability of object detection and scaling model to sort plastic waste in terms of precision and accuracy. And results demonstrate that scale yellow V4 outperformed the other models with the accuracy of 97%, mean average precision of 0.97, train time of 1.48 hours, and inference time of 0.02 seconds. It also outperforms the state-of-the-art image-based plastic waste sorting using color histogram method by 21%. And this research shows potential of using scale yellow V4 for plastic waste sorting if the motivation is for accuracy, mean average precision, and train and inference time. Now, this work can be further improved by including LDP, PVC, and other plastic types examples. Also by increasing the dataset size and also by optimizing the models with further hyperparameter tuning and training for more epochs. Future work could also explore using contextual features as feature enhancement technique as opposed to the feature pyramid networks used in this research. So with this, I would like to conclude my presentation. Thank you.
Thank you, Abhishek. Thank you for your presentation. Are there any questions? Let's see. Okay, I have one question to start. So you are doing this work for plastic recognition. So is it possible to extend this on all other kind of waste, so let's say on papers, on irons, on other dangerous maybe waste, so we can better recycle all the waste, not only plastic?
Yes. So to answer that, there are many studies performing this type of sorting. So smart waste sorting is already there in the research, but no one has done individual plastic type sorting. So you can find studies based on paper classification, waste sorting, so glass, paper, plastics, and other waste that is there, clothes and everything, electrical or even electrical waste. But when it goes to recycling centers, plastic needs to be further segregated into different types, so that it can be recycled. Because if you consider that there is a mixture of plastic waste into recycling centers, they cannot recycle that plastic because individual polymer types are different. And if you mix two polymer types, the resultant plastic will be resultant recycled plastic will not have a better quality, or it may not get out to the market because of its quality. So yeah.
Okay, thank you.
Yeah.
Other questions? I have one more. So if you know if these AI techniques are already being applied somewhere, let's say, and how and which technique and how they works. How meanings if they works well, so they are able to recognize well all the plastic or all the wastes.
Yeah, so to understand your question, I think you're asking that the technologies that I've used can detect other waste, you mean? Yeah.
No, just if yours technique or other technique are being now applied somewhere in the world. So if you know if some recycling structure are using really the AI systems to do this.
So yeah, I mean, I have not seen this before. So like when I was trying to find my research project idea, so I was surfing online, and also I was trying to check papers, research papers. So object detection models have not been used in plastic waste sorting. So yeah, so the thing was then, okay, so we need to try performing object detection on plastic waste only. So yeah.
Okay, there is one other question that is similar to mine from Joao here in the chat. They say, how easily can this technique be put to use? So okay, if it's easy to deploy this kind of technique, or you need a lot of effort to do this?
No, the only effort is training.
Okay, yes.
Yeah. The only effort is training, and also have to have a good data set. That's it. So
okay.
Mine was in my study, the data set was of only around 4,000 images. So if it gets like to around 10,000 or 15,000 only in plastic, only for plastic objects, then even good models, I mean, even the models can perform better and give more accurate results, and then they can be easily deployed over the cloud. Yeah.
Okay. Thank you.
Yeah.
Thank you. Thank you, Abhishek. I think that there are no more questions. Okay, we can go to the next one. Next presenter should be Emmie, right? Yes. Okay, let me check one moment. Okay, good. So Emmie Hine, sorry for my pronunciation, comes from the Oxford Internet Institute from Oxford, UK. She's going to present her work on informed digital consent for use of AI system grounded in a model of sexual consent. Sorry. Okay, the floor is yours, please.
Thank you so much. I'll just share my screen. Can everyone see my slides?
Yeah, sure.
Awesome. So good afternoon, morning, evening, wherever you're tuning in from. So my name is Emmie, and today I'll be talking about my paper, Informed Digital Consent for Use of AI Systems Grounded in a Model of Sexual Consent. So if you're here at this conference, it's not a surprise to you, the idea that AI systems are pervasive and shape our world. More specifically, they shape the infosphere, the sort of conglomeration of information, data, knowledge, communication that's populated by informational entities, including ourselves. So every song that's recommended to you, every credit card transaction you make, every time you log on to a social media platform, there are AI systems behind that are shaping your experience, shaping the information that you have access to. And this is, on the one hand, very convenient when you're looking for a great new playlist, but it also presents a tremendous threat to autonomy when these systems create echo chambers, when they increase polarization, or when they promote anorexia in teenage girls, as we saw in the Facebook leaks. So these threaten individual autonomy and impact both on and offline society. So, on the one hand, it makes interacting with others more toxic. Offline, maybe it provokes a riot, like we saw with January 6th Capitol attacks. So obviously, some some solution is needed to address how these systems impact individual agency and autonomy. And digital design ethics have been proposed, but are insufficient to combat the full scope of the problem. I argue that we need a system of informed digital consent, inspired by sexual consent as taught in American universities, in order to protect individual autonomy and agency, and even physical safety. So a quick roadmap, I'll start by outlining some approaches to digital design ethics. I'll move on to tolerant paternalism, which underlies informed digital consent, before discussing the sexual consent model and how it applies to this model of digital consent. And then I'll conclude by talking about possible implementation methods and addressing violations of informed digital consent. So digital design ethics broadly is the attempt to design ethical values into the digital. So one form is ethics by design, which enforces ethical values by designing to make some choices easier or harder. So for example, making everyone organ donors by default, when the ethical value you want to promote is organ donations. Structural nudging provides alternative options to shape an agent's environment and courses of action. So incentivizing organ donations with stickers or tax breaks or something. Pro-ethical design attempts to empower agents by allowing them to make choices based on information provided. So there are two forms: informational nudging, which provides information about the available options. So you could, give someone a pamphlet on the benefits of organ donation. And then mandated choice places a choice between the agent and an action. So maybe you make someone decide whether or not to be an organ donor in order to get their driver's license renewed. Mandated choice is a form of tolerant paternalism, which encourages the user to make the decision that is best for their welfare. Best is defined by the agent or body that is laying out this decision. But it enables and permits other behaviors. So you do this by making an action conditional on making a choice about something else. So that's the mandated choice. And it's tolerant because you tolerate if an agent makes other choices, but it's paternalistic because you are making them make a choice. However, it's insufficient for consent for the use of AI, of platforms that use AI systems, because in this case, a tolerant paternalism model of consent just makes a user decide, yes, I want to use this service with its AI systems, or no, I don't want to use this service with its AI systems. But it doesn't require that the agent be adequately informed about the possible impacts of using the service and its AI systems. So it does not enhance user autonomy. So American universities educate their undergraduates on consent. They're required under the Title IX legislation to combat sexual assault and misconduct on campus. And so usually as part of orientation week, students go to seminars on outlining consent and campus procedures and policies. Obviously, definitions vary campus to campus, but generally the form that they take, the four sort of pillars is that consent is affirmative, it is conscious, it is adequately informed, and it is able to be withdrawn. It's not a no means no model, it is a yes means yes. So it has to be active and enthusiastic and participatory. So now I'll outline how it applies to informed digital consent. So the affirmative tenet, it has to be positive, it can't be coerced. So requiring a de facto yes for the use of, requiring a, you have to require an active yes. You can't just assume consent or coerce the user into consenting. So you can't predicate the use of a platform of a service on consenting to being subject to its AI systems if the use of those AI systems isn't integral to the service. In terms of being conscious and adequately informed, so you can't consent to sexual activity when you are intoxicated or don't know what you're consenting to. So first, we need to remove the possibility of sort of an unsure or unconscious yes. So when I talk about an unconscious yes, I'm referring to something like the cookie banners that you just unconsciously click allow cookies on because they make it difficult to find the deny cookies or the customized cookies option, and they're so pervasive they're just like, yes, get this banner off my screen. That's not conscious informed consent, and there's precedent for this model of conscious consent in the GDPR. But to be tolerantly paternalistic, we must allow the users to choose, but they have to prove that they understand what they are consenting to. They have to prove that they understand the impacts of the AI models, of the AI systems that are being used. And so this could require an educational model and perhaps a quiz on the AI systems that are used by the platform. And I'll discuss more details later when we get to implementation. So derived from the informed requirement is that consent is dynamic and evolving. So, and also able to be withdrawn. So you consent to a specific activity. So if that changes, you have to change, consent must be reworked. You have to obtain consent once more. And there's always the opportunity for it to be revoked, even if a service hasn't changed. So under informed digital consent, a user has consented to the use of a certain AI system. If that system has changed, then they must be given the opportunity to, actively be presented with the opportunity to reconsent, withdraw their consent. And there must also always be the opportunity for them to withdraw their consent. So this will require effective interfaces and active communication from platforms. This could be inspired by the dynamic consent model, which is used in the medical field to allow medical patients to interact with doctors in medical studies. It can't be superficial, privacy checkup tools that platforms love to give users as sort of an ethics washing band-aid. It needs to allow users to decide what level of interaction with AI systems that they're comfortable with, so that they can be aware of those systems' impact on ourselves and our infosphere. Derived from all of these is an implied moral duty to avoid harm. So you consent to a specific activity with reasonably foreseen consequences, but if unforeseen or excessively negative consequences arise and another party in an interaction is aware, that other party has a duty to make the impacted agent aware of what's going on. So this is sort of a fiduciary duty on the part of platforms that use AI systems. So for example, Facebook, knowing that Instagram was promoting anorexia in at-risk teenage girls would be a violation of this fiduciary duty, or Facebook being aware that they were creating dangerous echo chambers that were increasing polarization in the wake of the election. Under this model, they would be obligated to intervene with those users and take steps to reduce the damages done. So now I'll talk a little bit about implementation. So I mentioned earlier an educational module, and I argued that platform-specific AI impact education seminars that help users understand the ramification of using the services and their AI systems are the best approach to ensuring that users are making informed, conscious decisions about whether to use these platforms. And I also argue that this isn't overreach, because responsible interaction with digital platforms, with with Facebook, with Twitter, is a new kind of civic duty. We have a responsibility to uphold societal order, and larger bodies, states, platforms have a responsibility to encourage this. So think about driving. We have a responsibility to behave well on the road, and the state encourages this with driver's education, with making older drivers retest for their license more often. So platforms have a responsibility to facilitate our civic duty to interact responsibly with their platforms, because of the impact that behaving irresponsibly can have on the infosphere. So these platform and platform-specific impact education seminars, they can have quizzes, they can even be user-specific. This is where the sort of trove of data that these platforms have on us could actually come in handy, because like for sexual consent seminars, often they will split students up into groups and take different approaches. So athletes may require a different approach than non-athletes. By that token, you need to adapt these seminars based on a person's language, based on their education level, based on their familiarity with technology. And platforms are well positioned to do this. In order to ensure that the consent is continuous, these seminars have to be updated when major changes are made to AI systems. And I'm not talking about a little tweak that fixes how text is displayed or something like that, but a major algorithmic change. And that should require users to retake the seminar, to retest, to prove that they have taken the seminar and adequately understand. And we should require refreshers, which will obviously vary in frequency depending on the magnitude of the system that we're talking about and how much it could potentially impact the infosphere. So your music recommender system may require less frequent refreshers than say the Facebook newsfeed algorithm. And these efforts will likely have to be centralized under a single body, as leaving it just to the platforms will likely result in inadequate or sort of ethics washed efforts. So obviously there will be violations of digital consent, and on American campuses, violations of sexual consent are addressed. They can be addressed by the university and/or the legal system. So that gives us two possibilities for addressing violations of informed digital consent: the legal system or some third-party body. Thus far, at least in America, the domestic legal system has proved itself not especially capable of legislating civic responsibility. So there's no national definition of sexual consent. It varies state by state, university by university. But then even for other more traditional civic duties, there's no, driver's education standards vary state by state. And so when you consider that platforms are international, then legislating domestically is likely to be insufficient. So we need a global third-party body that can, likely the one that is responsible for the education seminars, that can establish standards and have the power to sanction or fine platforms. In violation of informed digital consent could involve subjecting a user to an AI system that they weren't informed about, misrepresenting what an AI system is or does, changing a service and not informing users, or becoming aware of user harm and not intervening. And all of these would have to be addressed by this third-party body. So to conclude, I've outlined a new model of consent for the responsible use of AI systems called informed digital consent. And by taking inspiration from sexual assault as defined by sexual consent as defined by American universities, it protects user autonomy and will likely require a coordinated effort from the public and private sectors internationally to incentivize and implement. But by doing so, we can not only preserve, but enhance user autonomy and well-being. So thank you for listening. And if you have ideas on how to implement this, please feel free to reach out to me on Twitter at Emmie Hine. So thank you very much.
Thank you, Emmie, for your presentation. So let's see if there is some question from the audience, from here on the chat or on the Gather Town. Okay, is this one from Joao? Okay. You mentioned that these efforts will need to be centralized under a single body. Is it feasible and how?
So that's a great question. I mean, we have global bodies like the WHO, the UN. This could potentially be delegated to one of them, but again, it requires massive buy-in from the platforms themselves, and that's unlikely to happen unless they are incentivized either legally or otherwise to adopt these seminars. You know, no platform wants to put this big barrier that's, you know, an educational seminar and a test between users and their platforms. They want people to sign up, to be able to sign up and start using their platform immediately. But that's not the most responsible. That's not the most responsible option. So we need to incentivize the responsible option.
Okay, thank you. Any other question? Okay, another one from Marta. In theory, the idea of adequately informed consent makes intuitive sense to me. Do you have any idea on how an adequately informed model of sexual consent could look like in practice? Which criteria should it satisfy in order to be considered adequate, and who should set those criteria?
So the question is, how do we know if consent is adequate?
Yes.
Okay.
Yeah.
I think for informed digital consent, it's easier because you can establish you can create some sort of quiz and establish a threshold of what percentage of questions do you need to get right in order to pass. For sexual consent, it's more difficult. Nobody's presenting their partner with a 10-question quiz, but that's where the sort of dynamic and evolving model tenet comes into play. Consent needs to be a conversation, a dialogue between all the parties involved, and so this is where it's important to be aware and to be conscious of the experience of all parties at stake, and to keep in mind your responsibility to ensure that no one is being harmed beyond what could have been predicted or consented to. So really the idea of I've heard of the metaphor of consent as a cup of tea. If you haven't seen that video, it's worth a Google, but I prefer the idea of consent as a conversation. And if in a conversation you want to make sure that everyone knows what's going on and what's being discussed.
Okay, thank you. There is another question from the Gather Tunnel, but I think that is the same question that you already replied before. So okay, I think that we are done, and we go through the last paper presentation of this first session. That is from Amar. Okay. Okay. Amar Singh from the University of Wuppertal, Germany. He's going to present his work on René Laloux's vision of Ecotopian AI, exploring the ecosystemic AI through Fantastic Planet.
Yeah.
So Amar, this is your floor, please.
Yeah, thank you. Yeah. Is my screen visible here?
Yes, yes.
Okay. Okay. So as just mentioned, the topic of my presentation is René Laloux's vision of Ecotopian AI, exploring the ecosystemic AI through Fantastic Planet. This paper I've co-authored with Shipra Tholia, who is my colleague in the same university. Now, again, before I could begin with my presentation, I would like to make one thing clear here. My idea of artificial intelligence that I'm dealing here, it comes more from the literature and film, and how like it is there out there in the popular culture jargon, so to say. And now, since I'm talking about popular culture jargon, artificial intelligence, there it comes more like a promise. Promise in the sense of like it gives us this idea that okay, humanity can go on doing whatever we are doing without present action, and there would be no consequences, as in future there would be like the artificial intelligence would be so powerful that we can geo-engineer the solutions, so to say. The planetary crisis could be evaded in the future, and even the same could be extended to the crisis that we are facing on humanity level. So since we are talking about future, a future always, like in the present, it always comes with the idea of time traveling. So there's this one article by Malcolm Quinn, Plot Against the Future, where he talks about the scenarios that arises when we do time traveling into the future. And he talks about the scenarios of satisfactions there. Now he says that, I mean, if you use a time machine, so to say, to travel into the future. So a time machine is basically, he calls it as a manifestation of our living time. And by this, he particularly means that like the time machine, which is made in a present, is made from the objects of desires of the present. So if you are making something from the objects of desire, so to say, of a particular era, and you want to escape to another era, you are basically taking those objects of desires into another era. So here arises the paradox that even though you end up into another timeline, you are still carrying those objects of desires. So still you won't be satisfied, so to say. Now, I'm bringing this idea here because this particular film, which I'm going to discuss here, it's a 1973 film made by great René Laloux, whose ideas, I don't know how many of people might be knowing him. He's a very popular French animated film director whose ideas have been so-called, I would say, copied in Hollywood a lot. Even like Avatar and all, they have used his ideas. So this particular film, which he made in 1973, which talks about future, when we see it in the present, we don't find, that a lot has changed. The things that he's dealing in 1973, we are facing at particular juncture. And when we look into the future with respect to, technological advancement and artificial intelligence and whatnot, he doesn't seem to be wrong at all. We feel that okay, we might still be facing these difficulties even in the future. So again, I would just like to give out the whole like what I'm what we basically dealt in the paper, that we try to examine the situations that the film brings forth, which becomes vital in understanding our relationship to the Earth at present and our role moving forward into the future. If humanity continues with its present actions, the future shall be one of unsatisfaction, because it will be framed through the objects of dissatisfaction of the present. Again, if we overhaul the system altogether, the future would still be dystopian, as the idea of satisfaction shall mitigate human knowledge. How can we then strike a balance to create a meta-stable structure of the future that can satisfy the needs of the humans and ensure the participation of other actants that have evaded human knowledge? Now, this particular film deals with these questions by showing how artificial intelligence can aid humanity to overcome its present crisis and lead to an ecotopian future. Now, this particular presentation of mine is divided into two sections. So one is the planetary crisis that we are facing at hand right now, and another is like artificial intelligence as a third space. So I would just give a brief idea of this film, that it deals with a dystopian future where there's this alien species, drugs, which is of planet Yagam. They enslave humans because humanity on Earth is completely destroyed because of maybe human actions or maybe natural occurrence, meteor explosion or something like that. So humanity on Earth has been destroyed completely altogether. And humans have been enslaved by drags, much more like companion species. This is a term by Donna Haraway, which is like the kind of relationship that we have with our domesticated animals. So to begin with this, to talk about this planetary crisis, I would like to start with James Lovelock's Gaia hypothesis, which basically could be summarized as life supports life. So in his book Nova Scene, he proposes that the idea that if suppose humanity, for whatever reason in future, it goes extinct, it would be a bad news for cosmos, because cosmos will it would lose its conscious memory. He says so because he believes that any advanced species that can travel galaxies should be electronic, and no organic life can do something like this. Now, it comes with a baggage upon human. This idea basically comes with a baggage upon humans, that he says that as humans, we need to be midwives or parents to future cyborgs, he says. And by like cyborgs, like we somehow in a way we already are cyborgs, but like he says, like cyborgs maybe to in the sense of to make electronic life or to develop maybe artificial intelligence, so to say, that can even sustain itself after humans are gone, so that the conscious memory of this cosmos can retain itself. So René Laloux, he gives the idea of what cyborgs in the future could look like. So drags, they are somehow like cyborgs, as they never die, they rejuvenate themselves like after a period of time. You can see in the first pic here on the top that they are playing with humans as companion species. These cyborgs, so to say, drags, they have moved from natural selection to intentional selection, as they use giant sex droids for reproduction. Now, coming to this idea of technology, philosopher Martin Heidegger, he says that technology is basically a way of revealing. Now, what happens in modern technology is that there's a catch, that modern technology, it conserves a lot and it doesn't give back to the system. So it disrupts the feedback loop. Philosopher Thomas Nail, he extends this idea and he introduces the kinetic ethics, where he talks about how matters are always in motion. He gives his motion philosophy, where he talks about that matters are pedatic, means they are random, they are always ongoing iterative process, that they are always becoming, and they are relational and immanently self-caused. So Thomas Nail, he proposes that rather than fighting with the entropy, we should help out our planet to die well. And by this, he doesn't mean that we should stop all our project and should, abandon our project and let everybody die. What he's saying is that, we, rather than looking into the past to a stable Earth, we should be rather looking towards creating a meta-stable structure that can sustain itself for a longer period of time. Now, artificial intelligence can support into this thing. But the problem is that being a part of the modern technology, artificial intelligence is again a part of the problem that we are sort of, I'm talking about, fighting against. So Kate Crawford, in her book, Atlas of AI, she calls this artificial intelligence as a part of the extractive industry, where this, where she says that this whole idea of extractivism of data mining encompasses and propels the old extractivism of traditional mining. So artificial intelligence, again, we can see there's a whole, behind every cloud computing and everything which we cannot see, there's a whole exploitation that goes behind of maybe in the form of human labor, of environment, of ecology. So again, coming to the idea of Thomas Nails, that we cannot abandon these projects and stop everything and think of that, okay, Earth will become stable, because it's not going to happen. It's a pipe dream, and which anthropogenic era has basically revealed to all of us. So what we can do, we can treat artificial intelligence as a third space where the exploitations of the past and everything that has happened till present, it can be fused into making something new. So third space is a term which was brought by cultural theorist Homi Bhabha, where he talks about how it's a hybrid position where new positions emerge. So so again, artificial intelligence can become a cure in that sense, where I would like to extend the idea of what the first presenter, Andrea, she was basically talking in her discussions, that this particular thing, like artificial intelligence, how it can bring other actors, the non-human actors, in dialogue, in conversation with human actors. So to see that, there's this Caesar and Lewis's art installment, Degenerative Cultures, where they had developed this digital fungus modeled upon this Physarum polycephalum. What it basically does is that it searches the internet for the text. It feeds upon the movements of the fungi, how it consumes oats, and it models its movement upon that, and then it searches the internet for similar kind of text, and it grows upon it. So what it does, that it is it is available on Twitter. The pictures are there, and everybody can go and see that. And it erases certain portions of the text. Now, what it does is that it enables humans to bring their anthropogenic projection upon what the non-human actor might be trying to convey to humans. So in that sense, because whatever humans do, they do through a human point of view. We cannot evade our human point of view, and that's the problem, and that's why there's so much of crisis, that we don't pay so much attention to other entities of this planet. So how to bring them, how we can connect ourselves with them. So artificial intelligence can become more like a conduit. It can bridge us with those non-human actors, and that is why I called it that it can become a third space. in the film also, René Laloux, he deals with this aspect where, like, these people, like the drugs, they are so marred by technology, they are so hampered by technology that just like we use Instagram and all and Facebook, and he displayed this kind of floating spheres, more like cloud computing, where everyone is consuming similar kind of thing. They are feeding same kind of knowledge, they are living the same kind of virtual reality, and it enables more of a technofascism. And based on this, they somehow they don't pay much attention to the crisis that is happening on the planet, which is geographical and geographical crisis, so to say, where one part of the planet is so hot and another is so cold, and habitable planet is left very very few spaces left there. So, and then there's this disregard for human intelligence, so to say. So what happens later in the film, that humans, they gain access to this artificial intelligence device that drags are using, and they gain their knowledge. And ultimately in the film, after a bit of conflict, they gain their freedom. So I'm not saying that something like this is going to happen with us, where artificial intelligence can enable other actors to, to free themselves, so to say, of humans. But what it can do is that it can bring what we are not able to understand, like this, I won't say language, but the kind of, like the pattern, if whatever we are not understanding, artificial intelligence can help us to understand this particular aspect. Because artificial intelligence, again, without human competence, it is basically nothing. Nothing in the sense, like, because again, going back to Kate Crawford's idea, that artificial intelligence is nothing, it's not an entity which is at particular juncture, that it is free in itself. Obviously, there are human biases that are projected upon artificial intelligence. But again, if we somehow detach ourselves from these biases and use artificial intelligence for these purposes, it can help us to, counter our biases, so to say. And we need to educate people also, to a general mass who are not, who basically gain all these information through maybe popular media like films and novels and graphic novels. And it can be done through narrativization, where narrativization basically means that, you attach an object and you give it a narration, which is happening with artificial intelligence as well, where we attach more like a dystopian idea. Again, it is more like projecting human biases upon AI there. But if we use it properly, there is more like an ethical angle can be attracted, which can maybe help us to compensate of whatever misdeeds we have done so far. So this is my presentation. Thank you.
Thank you, Amar. Very nice presentation. Let's see if there are some questions from the audience. Okay, I have one question. So the idea is that AI somehow is a third actor that will help, let's say, humans to improve or to improve their behavior, let's say. But there are also, taking this from this movie or starting from that. But there are also other movies that says that AI can that is not a good thing, but a bad thing, that AI will take control of our action, something like that.
Yeah, that's what I was actually trying to say. Maybe I failed to convey it clearly, that when we make like we bring about like these negative traits regarding AI in films, they are like I just recently read about Psycho psychonorman. Like the MIT developed this artificial intelligence psychonorman based upon this film Psycho, where like they fed the negative data of like murders and serial killers and whatnot on that AI, and they wish to see that, okay, what kind of result it's going to produce, and somehow it became Psycho. Yeah. So it's more like projecting anthropogenic biases upon artificial intelligence, like because right now we are hoping that maybe in singularity will happen in future and artificial intelligence will become powerful than combined brains of whole humanity, and somehow it will see humans as kind of an enemy. But as Stuart Russell, he says that smarter machines give wrong answers faster. So I mean, that's why I said the human competence is still needed with artificial intelligence. But when we bring all these projections that, okay, AI is going to be against humanity, it is somehow, we know what we are doing. We are somehow hoping that, okay, if AI or another entity will gain this much power, it is going to punish us. So it's more like human projection there. So
okay, so yes, so somehow this AI entity should have its own consciousness. Let's say it has not our consciousness that we bring to the AI system, but the AI system should create its own consciousness, so it will be a real third party and not only an extension of the human consciousness.
Yeah, I mean, that's why like AI should not only learn with what humans are doing, it should also learn through other entities of the planet, so that it can mitigate that aspect, like where if humans are trying to project too much of their elements, AI can predict, okay, how it is going to affect the other actors of the planet. That's what Caesar and Lewis's art installment it does. Like like it show there's a whole like students are discussing upon the videos are available on YouTube, where students are discussing, seeing the text, okay, how the digital fungus has erased certain portions of the text that it found on internet, and they are trying to read out, okay, bring their own readings, that, okay, how it is sort of maybe like trying to communicate to humans as in its own way, that you are doing something wrong. And I mean, these are again philosophical debates, whether it will happen or not. It's something to be seen. But I think if other actors are brought into this whole action of like developing artificial intelligence, I think there's a probability.
Okay.
Yeah.
Okay. Thank you. Any other question from the audience? Let's wait a few seconds because we have a little bit of delay from Gather Town, so let's wait.
Okay.
Okay, there is one here. Okay, okay. It's Joao from this chat from Zoom. The film was has very interesting ideas. I'm curious how you see drugs in reality.
Our drugs are more like we very much like humans, like what we are right now. We like when I proposed the idea that, okay, drugs are more like cyborgs, humans are cyborgs, because we are like, as Marshall McLuhan, the theorist, he says that technology today has become an extension of our whole reality, of our whole senses. So I mean, drugs are living in their own sort of simulated reality, and humans are at particular juncture, they are doing a similar kind of thing. Like we live in our simulated environment, we are surrounded with Facebook and Tinder and Instagram and whatnot, and we are consumed. We like this consumerist behavior that we display all the time. Humans are very much like drugs. So humans are cyborgs, drugs are cyborgs. So that's what I sort of correlated while watching the film.
Okay, thank you. I saw one raised hand on Gather Town. So please, Osama, let's say write on the chat if you want to make some question. Or it's only my impression, right? Okay, no, we removed. Okay. Maybe it was my problem with it. Okay, thank you. Okay, there is one question here. It is interesting, the idea of AI to free people. Right now, we see mostly the opposite with AI. Do you think that we will go towards that?
I mean, again, it depends upon like whether we are able to mitigate our anthropogenic biases. We want to do that or not, because if we bring other actors and other elements of this planet and we let the AI learn through their patterns, I guess it may happen. But at present moment, the way we are going, at current juncture, I don't think that that's what's happening. But maybe in future, who knows? Like we may somehow decide that in 2030 there's a whole, maybe like people decide, nations come together and they decide that okay, we need to create this ecotopian future, so to say. So, and
yeah, thank you. Thank you for your presentation. I think that there are no more questions. This was the last presentation of this paper session. So we will meet. We have next in the program. We have our keynote speaker Priya Donti. So that starts at 4 p.m. Central European time. So let's see in half an hour, I would say. Thank you, everybody. Bye.